If you stop watching now, you will miss one of the hidden battles happening inside almost every piece of technology around you. Your smartphone, your Wi-Fi router, your car's radar system, and the satellites connecting our world all depend on something that humans cannot directly see: invisible electromagnetic waves. They travel through the air every second, carrying information across cities, oceans, and even between Earth and space. But this creates a strange problem. How do you design, control, and improve something that your eyes cannot detect? How can engineers fix problems that are happening in an invisible world? The answer is hidden inside a strange circular diagram that looks almost impossible to understand at first. A diagram that became one of the most important tools in electrical engineering: the Smith chart. To most people, the Smith chart looks like a confusing collection of circles, curves, and mathematical lines. It does not look like a revolutionary invention. But for engineers working with radio frequencies, antennas, and wireless communication, it represents something much more valuable. It is a window into a world humans cannot naturally observe. Every wireless signal is constantly dealing with invisible challenges. A signal leaving an antenna does not simply travel forward. Part of it can be reflected back. Part of it can interfere with itself. Part of its energy can disappear because the system is not perfectly matched. This invisible struggle determines whether a device works perfectly or performs poorly. Imagine shouting inside a tunnel and hearing your own voice return as an echo. In electronics, something similar can happen. When electrical energy reaches a component that does not properly match the rest of the system, some of that energy is sent back toward the source. Engineers call this impedance mismatch. It may sound like a small technical detail, but it can create major problems. A poorly designed antenna can lose efficiency. A communication system can become weaker. A satellite signal traveling thousands of kilometers can suffer from tiny imperfections. The challenge was never just creating technology. The real challenge was understanding the invisible behavior happening inside that technology. Before the Smith chart existed, engineers had to rely heavily on complicated calculations. They could describe what was happening mathematically, but understanding the complete behavior of a system was difficult. In the 1930s, engineer Philip Smith created a visual solution. Instead of seeing endless equations, engineers could now see relationships between electrical properties in one organized image. The chart transformed complex mathematical relationships into a visual map. Resistance, reactance, reflection, signal performance, all connected together. The Smith chart did not make invisible waves visible in the same way a camera makes an object visible. Instead, it translated invisible behavior into something the human brain could understand. Today, the invisible world controlled by engineers is everywhere. Every phone call, every wireless connection, every GPS signal, every satellite communication link. Behind all of them are electromagnetic waves moving through space. Modern technology continues becoming smaller and more powerful. But as devices become more advanced, the invisible problems become even more important. Engineers need tools that allow them to predict behavior before a device is even built. The Smith chart remains one of those tools. It connects the physical world of electricity with the human world of understanding. The strange truth about the Smith chart is that it is not actually showing us the waves themselves. It is showing us the hidden consequences of those waves. It is a bridge between something invisible in nature and something visible in human imagination. That is why this simple-looking diagram became so important. It gave engineers a way to explore a world that was always around us, but impossible to directly observe. The biggest discoveries in technology are not always new machines. Sometimes they are new ways of seeing reality. And the Smith chart represents one of humanity's most creative solutions, turning the invisible into something we can understand. From the first radio experiments to the wireless networks of the future, this strange diagram continues helping engineers control the hidden forces shaping our connected world. If you enjoy cinematic stories about hidden science, technology, and the discoveries shaping our future, subscribe to Factellix.